So now we start with hypothesis. Hypothesis, the word itself means a statement which we are trying to prove statistically. Okay. So let us understand different form of questions. But before we start the hypothesis question, let me give a brief about hypothesis. The statement that we are going to test here are based on the parameters. There are three parameters which we test. The mean, variance, and correlation. Mean, variance, and correlation. Basically, these are the three parameters that you require when you're going to pick up a security or going to make a portfolio. So these parameters, we are going to test the hypothesis. There is either a two-tail test or a one-tail test. What are the different forms of test, how to test them, and how to conclude whether the null is rejected, the null statement is rejected or failed to reject. That is what hypothesis is going to be. Overall, while doing the questions, I'll discuss you the background of it, but I hope you have already done hypothesis, then this might make sense. Otherwise, it's a very complicated topic. Okay. Let's start with the first question. Okay. There are a couple questions in what I realized about hypothesis, 20 questions here and probably more in the future, is that it includes almost all the variety. Correct? Let's start. The first one, analyst suspects in the most recent year, excess return on the stocks have fallen below 5%. She wants to study whether the excess returns are less than 5%. Now, as soon as you see in the statement, something written that what is the analyst wanting to test, plot it down. So she wants to test whether the excess returns are below 5%. Number one thing, this is a test of mean. Remember, three parameters, mean, variance, and correlation is being tested. This is the test where she's trying to test the excess return. So it's a test of mean. What is she trying to test? Whether returns are below 5%. They have said designate the population mean as mu, which hypotheses are most appropriate. Now, before even I look at the choice, one thing you need to understand is that in a hypothesis, the null and the alternate never has equal to sign. The equal to sign is always with the null. I'll repeat, the equal to sign is always with the null. So if less than, had they given me less than equal to, then I would call it null. But here they have said only less than 5. So it's an alternate statement. So the null statement will be greater than equal to 5. Remember, this will be the situation. Why? Because the null always has the equal to sign. The equal to sign is never with the alternate. Everyone understands this? Correct? So, conclusion, what happens here? They have asked me which of the one is the correct test. So definitely I will go with the B part. Okay. The B has null as greater than equal to, alternate as less than. Why so, guys? I'll repeat again, because the null always has equal to sign, which the alternate doesn't have. Had they given in the statement here excess returns are less than equal to, then I would have kept that as a null statement. Got it, everyone? Yes. By the way, it's a one-tail test. Next, which of the following statement about hypothesis testing is correct? The null hypothesis is the condition that a researcher hopes to support. See, the researcher always wants to prove that the null is rejected. If the null is rejected, automatically the alternate is accepted. But statistically, we cannot say the alternate is accepted. So that's why we use two statements. The null is rejected or failed to reject. Now in hypothesis, we are actually trying to prove the alternate, and that is only possible if the null is rejected. So here the question, which of the following statement about hypothesis testing is correct? The null hypothesis is the condition that the researcher hopes to support. No, the researcher wants to reject the null, so the alternate is accepted. The alternate hypothesis is the proposition considered true without conclusive evidence to the contrary. Okay. See, this is an interesting thing. If they are saying alternative hypothesis is the proposition considered true without conclusive evidence to the contrary. Now, I'll repeat again. Statistically, we cannot say the alternate is true. We can only say the null is rejected or failed to reject. So this might seem very awkward to many students that if the null is rejected, the alternate is accepted, right? No, we don't say that statistically. We only say the null is rejected or failed to reject. It's like, you know what, when you go to a court, the court tells you that we do not have sufficient evidence, hence we cannot put you behind bar. But the court doesn't tell you that there has been no crime or you have not done the crime. See carefully, they don't say you haven't done the crime. They say that we do not have sufficient evidence to keep you behind bar. That's why you're free. Understood? That's the way statistics also works here, the hypothesis testing. So what is the third statement? The alternative hypothesis exhausts all the potential parameter values not accounted by the null. Yes. So whatever is not accounted in the null is accounted in the alternate. For example, in the previous question where the statement was the null is greater than equal to. So whatever is missing goes to the alternate. If it's a two-tailed test, null is, let's say, equal to 5. The alternate is not equal to 5. So everything that is not there in the null, it is there in the alternate. So question number C is a correct statement. Understood, everyone? Which of the following statement regarding the null is correct? It can be stated as not equal to. Wrong. Null always needs the equal to sign. To provide the alternative hypothesis. So A is wrong because it says not equal to. Remember, null always has the equal to sign. Along with the alternative, it considers all possible values of the population parameter. Yes, because as I mentioned in the previous case, the null and the alternative together, they have all the possible outcomes. So whatever outcomes you do not have in the null, those are included in the alternate. Clear? So the answer is B. Let me also look at C and tell you what is wrong with C statement. So in C, we have here in two-tail test, it is rejected when the evidence supports equality between the hypothesized value and the population parameter. It is rejected when the evidence supports equality. No, whenever two things are equal, we say fail to reject. So C is also wrong. Correct? Next. Which of the following statement regarding one-tail hypothesis test is correct? Okay, guys, how does a one-tail hypothesis look like? Let's say if I say that hypothesis is right tail, it will look something like this. Okay. Here, the rejection region increases in size as the level of significance becomes smaller. Let me test. This is my level of significance. Let's say this is 5%. And this is my critical point or critical value. Question number 1, they say that the rejection region increases as the level of significance becomes smaller. No, as the level of significance goes from 5 to 10, the rejection point will increase, not decrease. So A is wrong statement. B, a one-tail test more strongly reflects the belief of the researcher than a two-tail. Yes, this is true. For example, sorry, I think Zoom sends some balloons. I don't know why. So, for example, what happens here that if it's a two-tail test, let's say a two-tail test for mean equals to 0 or not equal to 0. So if the null is rejected, it only tells you that it is not equal to 0, but you don't know whether it is greater or less. So one-tail test is more specific. It's more informative. It is one step higher than the two-tail test. So one-tail test being correct means I can not only reject the null that it is equal to 0, but I can also say whether it is positive or negative. So a one-tail test is more powerful than a two-tail test. Therefore, one-tail test more strongly reflects the belief that the researcher than the two-tail test. The B statement is the correct statement. C, the absolute value of critical value is larger than that for a two-tailed test at the same level of significance. What does this mean? Well, this means that, let's say for the Z value for a 5% alpha, I'm considering Z value for a 5% alpha. If it is two tail and if it is one tail, what are the values? So if you recollect the values for two-tail 5% alpha, the Z value is plus minus 1.65. But if it is on one side, if the entire tail is on one side, sorry, my mistake, for a two-tail, the value, this is for one tail, for a two-tail, the value is plus minus 1.96. But if the entire tail is on one side, its value is as much as 10% on both sides. So 5% on one sided, its value is 1.65 or 645 to be precise. And two tail, if it is then 1.96. Now, what is statement C saying? The absolute value of the critical value is larger than that for a two tail. No, for a one tail, the value is actually smaller than that for the two tail. Understood? So statement C, it's very complicated, not so easy. Statement C is wrong. B is the correct answer here. Clear? Next, if the researcher selects 5% level of significance for hypothesis, the confidence level, well, 5% is the significance, then opposite is the confidence level. Very easy question. This is going to be 95%. Everyone with me? 5% is significance, so 95% is confidence. Okay, everyone? Yes. See, these are the basic questions related to framing the hypothesis. Okay, so whatever questions I've done here, when you do hypothesis, it will help you whether it is a one tail or a two tail, what is the null, what is the alternate, how to define the critical values. That is what you'll get to know from this part. Okay. Now, what I've noticed, the questions that you have are related to type 1, type 2 error. My experience says that type 1, type 2 error is very, very, very important from your exam. And I remember from the days when I had given exam, it is very frequently asked. Historically, many students have the experience of seeing type 1, type 2 error. So this is a very important thing. Okay. A hypothesis test for a normally distributed population has significance of 5%. Guys, whenever you have a significance of 5%, that means there is a 5% possibility of your test being wrong, 95% probability that your test being correct. That is a general philosophy. Okay, so our significance is 5%. What does it imply? 95% probability of rejecting a true null, 95% probability of type 1 error for a two tail, or 5% critical value rejection. C is the answer. So when 5% is the level of significance, means there is a 5% critical value rejection. My rejection zone, suppose if it is two tail, so my rejection zone, this 2.5 on both the sides, total 5% is my rejection zone. Okay. Now they are saying 5% critical value rejection for one tail. If it was one tail, the entire 5% is going to be on one side. So the whole 5% is on one side. Understood? A and B are incorrect statement because A says 95% probability of rejecting a true null. By the way, rejecting a true null is type 1 error. Type 1 error is equal to alpha. So A is wrong. 95% probability of type 1 error for a two tail, both A and B are the same statement. The value of test statistic best described as the basis of deciding whether to, as I mentioned, the purpose of the test statistic is to reject the null so that the alternate is accepted. Okay, so our objective of here, the value of test statistic is best described. How can I say reject the null? I compare the critical value, but critical value cannot tell me whether the test is rejected or failed to reject. For example, the 5% critical value, 5% alpha two-tail critical value is 1.96. Now, this cannot tell me whether the test is rejected or failed to reject unless and until I see the test statistics. If the test statistic is in the rejection zone, only then I can conclude the test is rejected or failed to reject. So the value of test statistic is used to generally is going to be the basis of deciding whether to reject a null. Why not B and C? Because we never say statistically accept the null or we never say reject the alternate. We always say whether reject the null or fail to reject the null. So it's more about the statement. Which of the following is best described as type 1 error? Remember, type 1 error is the error of rejecting a null when it is true. So rejecting a true null hypothesis is type 1 error. Failure to reject the false null is type 2 error. If rejecting a true null is type 1 error, not rejecting a false null is type 2 error. So failing to reject a false null, ninth B, is the type 2 error. Understood? The level of significance of hypothesis is best used to. Why do we use the level of significance? Why do we use this level of significance? This is the level of significance alpha. This gives you the critical value. Understood? Based on this critical value, you will decide and compare that with the test statistic. So these critical values are called the rejection points. Basically, if your test statistic is below or above this critical value, then you reject the null. So what is this critical value for? What is the purpose? Its purpose is to define the rejection points. I call it, in my class, I call it as the borders. These are the borders. If your test statistic breaches that border, then the test is rejected. Understood, everyone? Yes. The probability of correctly rejecting the null hypothesis. Correctly rejecting the null is, so first of all, failure to reject the null when it is false, failure to reject the null when it is false, it's a type 2 error. Okay. But correctly doing that, the probability of correctly rejecting the null, that's 1 minus type 2 error. And that 1 minus type 2 error is called power of test. Power of test is 1 minus type 2 error. It is in fact the, it's a point which says your hypothesis is how accurate your hypothesis is, how powerful your test is. So if you've correctly rejected the null, remember our objective is to reject the null. If you've correctly done that, 1 minus type 2 error, that's called power of test. Got it? Same thing, the power of hypothesis test. Again, it's the same question. It's the probability of not making type 2 error. As I said, power of test is also called 1 minus type 2 error. I'll repeat, power of test is also called 1 minus type 2 error. Type 2 error is failure to reject a false null. So correctly rejecting the false null is 1 minus type 2 error or power of test. Got it, everyone? Next, in the step stating the decision rule. Stating the decision rule is testing a hypothesis. Which of the following element must be specified? So see, this is one of the very standard question in hypothesis. Generally, the steps of hypothesis. In the steps of hypothesis, I'll just give you a brief idea. In the steps of how do I design the hypothesis and conclude. Okay. Number one is you have to state the hypothesis. You have to state the hypothesis. Sorry. State the hypothesis means I have to decide what is the null based on the information in the question. We will conclude what is the null and what is the alternate. Then you have to state what the appropriate test statistic. We are not going to calculate here. We are going to decide what is the appropriate test statistic suitable for my test. For example, if it's a mean, you might use a T or a Z test. If it's a single variance, chi-square. If it is two variances, you use F distribution. If it's a correlation, it's a T test. So which test is suitable? That is step number 2. Then the next step is you state the level of significance or the alpha. Okay. Based on these two things, then you make up a decision rule when to reject, when to fail to reject, collect the sample, and then do the calculation. So here in step, stating the decision rule. Stating the decision rule is after these 3 steps. After these 3 steps, we will make the decision rule. Decision rule means, see, null and alternatives I got, but when will I reject the null or fail to reject? That will be decided in this. And after this comes the calculation. You collect the sample data from the question, and that you compare with the rejection points of critical value and then conclude. So they asked me in the step stating the decision rule in testing hypothesis, which of the following elements must be specified? So of course, I need the critical value before I conclude what is going to be my decision, whether I will reject or fail to reject. Before I reach that point, I need to have the critical value. Critical value, guys, remember the three critical values that are tested in exam, not only in your level 1, but in your level 2 or 3 also. It will be 90% confidence, 95% or 99. The same if I say the in other way, 10% alpha, 5% alpha, and 1% alpha. Okay. So the answer is critical value, power of test not, and value of test statistic. Value of test statistic, guys, is not going to be the, it's going to be after my decision rule is made. Then I will compare the critical value and test statistic. I'll calculate and then I will conclude. Okay. So value of test statistic comes after the decision making, not before the decision as to what is to be rejected and under what condition you should fail to reject. Okay. Clear? Yes. Next, pooled estimator. Pooled estimator is used to testing hypothesis. Now, first of all, for a single mean, if there is only one sample, for a single mean, you use Z or a T test. Pooled estimator is used when you are comparing the differences in mean, but the assumption is that both of these samples have equal variance. That's in B. A, equality of variance of two. No, for that you have F test. Differences between mean of at least two normally distributed population with unknown and assumed unequal variance. For this, you use a T test. But for this, we use a test called the pooled estimator when the variances are equal. So it's again differences between mean of two samples, correct, to normally distributed populations. But whenever they say equal variance, we use a pooled estimator test. This is where you calculate the differences in mean. Instead of just taking mean, you take the difference of both the samples mean. Okay. When evaluating mean difference between two dependent sample, that is called the pooled estimator or the paired comparison test. The most appropriate test statistic is the paired comparison, not Z test. Z test is for single mean, chi-square is for single variance. Got it? Chi-square, as I said, chi-square is the test for single variance, very easy. And which test should be used to test the difference between variances of two normally distributed? For two variances, there is only one test, F test. Understood, everyone? Correct. So if you see broadly, for single mean, there is Z or T test. For two means, paired comparison or pooled estimator, generally a T test. For single variance, chi-square. For two variances, we have F distribution, and later on we'll see test for correlation. We also have T test for correlation. All of these mean variances and correlation, these are parametric tests. All of these are parametric tests. When your data does not meet the assumptions of parameter, like let's say the sample size is less than 30, which is considered too small. So whenever the sample size is below 30 or the distribution is non-normal, in such a case, or when the data is ranked, okay, or the data is in series plus minus run series, in such a case, we cannot use a parametric test. So we use a non-parametric test. Non-parametric test. This is most appropriate when the data considers something like rank. Guys, rank, I cannot put up in a normal distribution. Okay, so rank is a non-parametric test. Validity of the test depends on many assumptions. No, when the assumptions are met, it's a parametric test. Sample size are large, again a parametric test. A, rank, non-parametric test. Now, the irony here is that the next question is also the same thing, in fact. If you will see, in which of the following situation a non-parametric test for hypothesis is most likely used? When the sample data ranked according to magnitude. So I generally feel 18 and 19 are, I think they probably have kept the same question in a different word. It doesn't make any difference. 18 and 19 are same. The answer is also same. one issue I have with the CFA Institute is that after this, they have kept another topic called parametric and non-parametric test. In that, they've kept the test of correlation. And in this topic, they've discussed parametric and non-parametric. So when you have already a topic of parametric and non-parametric, why put that theory in hypothesis also and in that topic also? In that topic, you have test of correlation. Rather, they had put the test. I mean, it would be suggested if, first of all, previously they were all same topic. Hypothesis and parametric test were together. They thought it's too big, so they separated it. But I think they have made some goof up there, because parametric, non-parametric information is in hypothesis and the topic is after this. So I don't know what's wrong there. Next, an analyst is examining the monthly returns for two funds over a year. Returns for two funds. Okay, whenever there is returns for two funds, it's going to be which test? Normally, if it meets the parameter, you have a t-test, paired comparison, or pooled estimated test. Both funds return are non-normally distributed. Okay. To test whether the mean returns of one fund is greater than the mean of another, the analyst must, okay, guys, first of all, always when it is non-normal, I don't use the non-parametric test. But in this case, they have said the return for two funds over 1 year and monthly returns. Monthly returns over 1 year means my sample is going to be less than 30. Why? Because n is 12, isn't it? So monthly return for 1 year means n is 12. Now, whenever the sample size is below 30 and the distribution is non-normal, then you cannot use the normal parametric test. Then you'll have to use a non-parametric test. Understood? So two things. When the sample is less than 30 and the distribution is non-normal, so I cannot use a parametric test. I'll have to use a non-parametric test. Got it? Everyone? Clear? Okay. Now, this is where we finish this topic. The next topic is parametric, non-parametric. There are only very few questions about it. And I repeat, I don't know why the CFA Institute has kept that separate. Okay. So what I'm going to do is that we are going to do those two questions also along with this hypothesis only. So let's do the non-parametric and parametric test of independence. Here, even though in your notes it says test of independence, but they have also put the correlation test into the parametric and non-parametric. Okay. First of all, let me discuss for correlation. Correlation, there are two tests. One is a parametric, another is a non-parametric. The non-parametric test, we don't do it for our exams. The non-parametric test is called Spearman rank correlation test. Okay. But the parametric test we can do. For a parametric test of correlation, the null and the alternate. The null is always that the correlation is 0. The alternate is not equal to 0. So it's always a two-tailed t-test. It's always a two-tailed t-test. And here the test statistic formula is slightly complicated. If you are lucky enough, you might get that ready-made in the exam. Okay. So here it is correlation into the degree of freedom square root n minus 2 divided by 1 minus correlation the whole square, correlation square, not the whole square, sorry, and the square root. It's quite a complicated thing. But what we are going to do is that we will plot our test statistics against the critical value. For critical value, they will provide us with the either with the critical value or the table in the exam. Okay. Let's see the question. Jill is analyzing how the returns on the stock are related with the previous month's percentage change in the US Consumer Price Index based on 248 observations. So n is greater than 30. So I will use the t-test. She has computed the sample correlation between the stellar and CPI ENG variables to be this. So I get my correlation. She also wants to determine whether the sample correlation is significantly different from 0. So yes, we are determining whether the correlation is 0, null, not equal to 0, alternate. Critical value for 5% is given to me as 1.96. Normally, this is Z value. For T, it has to be slightly higher, but it's okay. They've given us, so I will keep that 1.96. Let's calculate the test statistic. For test statistic, I have the correlation with me. So here, my correlation is 0.1452 minus 0.1452 into n minus 2. The n is 248. And why minus 2? Because in correlation, you have two variables. So n minus 2. So this will be 246 square root, 248 minus 2, 246 divided by 1 minus 0.1452 square and then the square root. Okay, it's quite a complicated thing, but how you will solve it? Generally, I solve the denominator first. So 0.1452 negative square is always this plus 1. Why? Because minus minus. When you do, the interesting thing is that, okay, let me tell you, the denominator is 1 minus this minus square. So if you solve this, the denominator will still be 1 minus, okay, let me solve 0.1452 square, you'll get 0.021, store it. Then you can do 1 minus this, you might get 0.97, store it. 0.97892, I keep it stored. The numerator I solved, 246 square root into 0.1452 negative, divide by this, you will get approximately 2.3. Are you getting this? 2.3, everyone? Right? You'll get 2.3 and 2.3 is higher. So this is negative 2.3, not positive. So negative 2.3 is in the rejection zone. Understood? Everyone getting 2.3 negative? Yes, correct. 2.3017 to be precise. So when you solve this negative 2.3017, it falls into the rejection zone. So what should I conclude about the relationship between these two variables? That when I say here, my decision will be reject the null. My decision will be reject the null. The null is that I was supposing the null as there is no correlationship. So now I will conclude that since I reject the null with 95% confidence, I will conclude that there is statistically significant relationship. So let's see the choice. Significant, yes. B is significant, C is insignificant, C is not the answer. Let's see between A and B. Significance because the calculated test statistic is outside the bounds of the critical value, yes. It is lower, no. So the answer is A. It is outside the bound. Only then you reject the null. Clear, everyone? Yes. A more detailed analysis of how the test of correlation is done, that is uploaded on my YouTube video where I've done the hypothesis test in detail. Okay. Which of the following is correct regarding the chi-square test of independence? First of all, test of independence. In this, we are testing the it's a contingency table, where in the contingency table, you are basically going to compare, I should not say two variables. These are two, for example, let's say you have earnings data on one side and you have stocks revenue on the other side. So it's a comparison. It's a comparison of two groups. Okay, so you can say two categories. So it's a test of two categories, or you can say two variables also. So here I'm testing whether they are independent or not. So my null is whether they are independent, and the alternate is they are not independent. Okay, this is what we are testing. So that's my test of independence. I'm comparing the two variables. Now the test has a one-sided rejection zone. No, it is what? Here, one-sided rejection region. Which of the following statement regarding the chi-square is of independence is correct? The test has one-side rejection. No or yes? Yes. Why? Because guys, generally chi-square test, where chi-square is basically for variance, and variance are square of the standard deviation. So can the square of anything be negative? No. The square of anything can never be negative. Therefore, these are always right side test because they are never going to be below zero. So these tests are one side. They have rejection region of one side, even though it sounds like a two-tailed test, but they are bounded by zero. They cannot go below zero because variance can never be negative. So yes, chi-square and f distribution for both, because it's a square, it can never be negative. So yes, the answer is A. But let's see why B and C are not the answer. B says the null hypothesis is that the two groups are dependent. No, the null is that the two groups are independent. So B is wrong. If there are two categories which there are three levels or groups, there exists 6 degree of freedom. No. See, in the test of independence, the degree of freedom is column -1 times row -1. So here two categories are there, rows and columns, three levels of each. So 3 minus 1 times 3 minus 1. So 2 into 2, that is basically the answer is going to be 4. My degree of freedom has to be 4 and not 6. So C is also wrong because of this. Understood? I know this sounds a bit complex and all, but I recommend you to watch my hypothesis and linear regression, video in detail. There I've explained what is to be done in exam with respect to test of independence, what you need to remember and what you can probably take a risk of skipping. Perfect. This is where we close that. I generally do, and I recommend you all to do hypothesis and parametric and non-parametric test of independence together because they were previously only one topic, right? Any questions? Anyone? This might sound complicated. I recommend you all to do this only and only after you've gone through the hypothesis and linear regression. Thank you so much. If any queries, let me know. Okay, anyone, any questions? Okay, thank you.